Hey everybody, I'm Jason, and this is Jay's Project Garage. So it's about 7:30 on Tuesday, day 4 of my vacation. It's pretty awesome. So my last video from yesterday did pretty good overnight. It's got like 35 views. So thank you guys very much for watching. Also, if you have any interest whatsoever in Ford engines, transmissions, Ford Mustangs, classic Fords, 31 Model A, we're going to be working on it because my wife's been bugging. And for you GM guys, don't feel left out because we're going to be doing big block and small block Chevy stuff. And I've got that Oldsmobile we got to figure out what we're going to do with. I'm kind of thinking about doing a blow-up video. Like how long will it last at wide open throttle? I mean, if it even turns. Look, do we get it to turn and then send it? And also, don't forget about my giveaways when I get to 100 subscribers. Every video after 100 subscribers, I'm going to be giving stuff away, and all you have to do is figure out what the movie quote is in the video, and be the first one to post it in the comments, and you win stuff free. I even pay shipping and handling. And I'm even thinking about taking suggestions on what to give away. So if you guys need something, post it in the comments, and if I've got it, that's what's going to be available in the next video. So, was it yesterday? Was it last video or the video before? I think maybe it was the video before. I was talking about 5-liter Ford blocks wanting to saw themselves in half. But I'm going to explain to you guys how that happens. And I also made a comment about harmonics being the thing that breaks these. Obviously, that's not the only thing. But that's what we're going to talk about today. So let's get to the lame action. Hey, it's a 5-liter. Okay, so when you hear somebody say something about the main web, this is the main web. This area that goes from the side of the block to the side of the block. And from the cam tunnel all the way through here. Now, these things are super thin in here. And that's just kind of an inherent problem with the design. The bores are so close that there's just not a whole lot of room there for a bunch of meat. I would bet that on this late model block, that's like less than 1/4 of an inch thick through there. You can kind of see. Now there is room for more iron. And the earlier blocks had more iron in them everywhere. Now what I'm going to do, I don't know, it's not going to be in this video, but soon, I'm going to take a late model block, and I'm going to take that Mexican block, and I'm going to take an early block, and I'm going to throw them on a scale, and we're going to see how much of a difference there actually is in the 3 of them. But the lifter valley is very thin on these too. Through here, I've seen these things start to crack through here first, and I've also seen them start to crack from the oil hole down across. It'll work its way down. Either it'll go through the cam bearing or it'll go around it and right through the center, and then before you know it, you've got a 2-piece 302 block. Now in an NA application, what kills these things is harmonics. And harmonics is caused by RPM or the 28 to 50 ounce imbalance. Think of it like vibration. The harder the cast iron the harder any metal is, the more brittle it is and the more crack prone it is. So Ford used chromium in these things to make them more wear resistant. And another effect is basically just makes the iron more brittle. So it's going to be more crack prone. Now if these things were made out of something soft, they may not have had as many problems, but you always hear that magic number. These things are only good for 500 horsepower. Well, I've seen them making a whole lot more than that, and then I've seen them turn to stupid RPMs. It's all in the prep work. So harmonics are bad and good. And like I was saying in the other video, if you internally balance one of those things and get rid of some of the wet noodle effect, the factory stuff will work out great. I've seen something else where guys are talking about, well, those things are junk. I've seen those things cracked in production factory applications. You know, I'll go to the junkyard to pull an engine out, I'll bring it back, and it's got a split in it somewhere. Problem is, you're making assumptions, uneducated assumptions. You have no idea what the history of that engine is. Did it run with the wrong flywheel on it? How many years did it spark knock? You don't know what the thing was used. How many times it was overheated? You don't know. I mean, I've pulled small block Chevys apart that had splits in them. The last one I built not too long ago, took the block to the machine shop and it had a crack in the side of it and a split in the cylinder wall that I didn't see when I was taking it, but I went over and watched them Magnaflux it and they were there. I mean, we're talking about stuff that's 30, 40, 50 years old. It's prepped correctly. I've built a bunch of those things that are in the 4 to 450 to 500 horsepower range, shifting at 660, 500 with no problems. I've never personally had a block split. You go putting a turbo, a big supercharger or something on it, and we'll talk more about the supercharger scenario here in just a minute. But RPM on stock components. And this is a Ford 302 connecting rod. This is a C8, so a 1968 302. These are forged. They're actually really good, pretty good production rods. Like I said in the last video, the downside is that 5/16 bolt. Now you can see the connecting rod, how much meat there is. Now there's enough there for a 5/16 bolt. But if you go trying to drill it out, I don't know if you guys can see that. That's a 5/16 bolt. That's a 3/8 bolt. This is the bolt that the Hypo 289 had in it. If you go taking a rod that had a 5/16 bolt in it, and you drill it up for 3/8, look at all that material you're losing. That's a lot. It weakens the big end of the rod. There's not a whole lot there. You go taking that much material out, I would seriously worry about the big end of the rod breaking. I've seen a whole bunch of blown up engines over my career. I've taken quite a few of them apart. Hang on a second. Don't move. Hold on. Are you still there? This is out of a Chevy 400 small block. Almost every single one of these things I've ever seen blown up, every engine I've ever seen blown up with some kind of a rod failure has been the result of a rod bolt. Obviously. I mean, it's been very apparent that the reason was a rod bolt failure. Now, whether it was the bearing went bad and the big end of the rod just beat itself to death and it finally broke a bolt, or if the thing had been rebuilt 100 times and they kept reusing the same rod bolts, it was just fatigued and it broke. But almost every single time I've seen an engine blow up, it's been because of a bolt. And it's big at the big end of the rod. So, if you're using stock rods and you're not planning on turning over 6,000, just get a good set of ARP bolts and put in it. Perfect. If you're planning on turning more than that, making a bunch of power, I would just step up to a good set of Eagle or Scat or whatever connecting rods. Okay, for a supercharged application, you've either got a Roots that sits on top of the engine, or you've got centrifugal that hangs off to the side that kind of looks like a turbo with a belt on it. A snail. The belt has a lot of tension on it, and when you start getting into boost, that supercharger puts a lot of load on the crankshaft. And I've actually seen the snouts break off. Or just that extra loading will intensify the wet noodle effect. And it'll wind up breaking a block. It's not just that, it's the pressure itself, and turbos are easier on parts but harder on parts at the same time, if that makes any sense at all. All of that cylinder pressure is trying to push the crankshaft out through the bottom. Pushing down on the pistons, it's pushing down on the crank. A lot of cylinder pressure is pushing down, trying to exit the crankshaft out the oil pan. And that's kind of the last thing you want, which is one of the places those thicker main caps will help. They're stronger, you're less likely to break a main cap, and it helps stabilize the bottom of the block because there's just more meat. So this is my D4 351 block that's 60 over that I think we're going to do the grenade experiment with. Put a 393 crank in it with the cheapest stuff I can find just to see what happens. Like I said, it's already 60 over. It's got some issues in a couple of the cylinders from water and it's sitting. This thing's junk. You'll see a lot of guys on the forums and on Facebook saying, oh, I'll just get a set of program 4-bolt main caps for this thing. The problem is there's just not enough meat in the main webs for that extra bolt. There's not really a whole lot of benefit. The idea of a 4-bolt main cap is the cap is stronger, yes, and also it helps tie the bottom of the block together with those 2 extra bolts. But if there's not enough meat there and you're drilling a hole in it, I don't think it's really a benefit. I think you're actually hurting things more than you're helping. And it's hella expensive. The caps themselves aren't cheap, and then the machine work to get them put in and aligned, bored, and honed is definitely not cheap. If you're spending a bunch more money, by the time you get one bored, honed, cam bearings, freeze plugs cleaned up, get a set of 4-bolt main caps put in it, get it aligned, bored, and honed, and everything else, you're into over $1,000. Do you want to spend $1,000 on a factory block? You know, back when the aftermarket blocks were only about $1,500, I mean, it was kind of a no-brainer, but now they're over $2,000. Now these blocks will handle north of 700 horsepower, and I've seen them making a lot more than that. But you're living on borrowed time. If you get a good aftermarket block, the composition of the iron's different, so it's stronger. You have the benefit of the 4-bolt main caps, you have thicker main webs, you have priority main oiling, which is definitely good. There's a lot of benefits to running an aftermarket block versus we want to run one of these. But we're not all Bill Gates. We don't all have that kind of money. I make pretty decent money, but I've also got a family I got to take care of. So I can't go spend, you know, $2,200, $2,300, $2,400 on an aftermarket block. I just kind of have to make what I got work. Luckily, I've got like 10 of these, so if I break one, it's not the end of the world. But everybody keeps throwing around this magic number. You know, the 351 Windsor blocks are only good for 700 horsepower. The 302 blocks are only good for 500. That's kind of an imaginary number. I mean, there is no magic number for every block. And a horsepower number doesn't really mean anything. Now, torque is an engine's ability to do work, and horsepower is how fast it can do that work. So honestly, RPM is what kills these things, and naturally aspirated. The faster you spin the thing, the faster stuff's happening, the more harmonics there are. Block split toe. So, proper prep work, internally balanced, use lightweight components, the lightest stuff you can. You can use a longer rod and making a shorter piston. You reduce the weight of the piston, you get more of the weight towards closer to the center of the crankshaft. That's the less stuff there is flailing around and the less harmonics and the easier it is on the block. Okay, something I want to add real quick. I don't know where I'm going to put this in the video. Somewhere. But a lot of guys, when they're building a fairly stout bottom end, they want to go all forged, they'll go straight for an H-beam connecting rod. Now, these things are fairly heavy compared to an I-beam. This is small block Chevy stuff. They still look the same. I just happen to have these sitting on the shelf. So an H-beam connecting rod is really good, but it's, like I said, it's heavy. So if I was going, you know, turbo or a supercharger or something, I might be tempted to use these. But honestly, if I'm just going naturally aspirated and I'm only going to be revving it to about 7,000, I'm going straight for an I-beam because it's lightweight. And I'm trying to cut down on the weight of the pistons and the weight of the connecting rods, and I want to try to get it as close to the center of the crankshaft as I can. The less weight you have flailing around, the less harmonics you have, and the easier it's going to be on the block. Stock block stuff. Just my opinion. Craig 909 is building a long rod engine for his truck. Well, I like the idea. I'm kind of curious how it works out. I don't even know if that's why he's doing it. I don't know if he thinks that the longer rods are going to make a bunch more power, or if he's doing it to try to get all the weight closer to the center, because he's planning on turning the thing 8,000. I'm going to be really curious to see how that thing shakes out. But he also had a whole segment on this Mexican block that he got. It's high nickel content, it's this and it's that. the Mexican 302 casting is identical to the early Ford. Same main web, same everything. The only difference is those main caps. That's it. And as far as metallurgy goes, I'm not a metallurgist. These are educated opinions based on what I've read. But the metallurgy of the Mexican block is actually lower quality than the stuff we have here. But the lower quality, softer iron may be what saves them. I guess that's it. I got stuff I got to do, man. I can't sit here and talk to you guys all day. I mean, I'm a busy man. I got a lot of stuff to do. Actually, I'm pulling wire. I'm working on the electrical. I'll be really glad when that project's done. You guys have no idea. But for now, you guys enjoy your day at work. And when you get home, get out in the shop and work on your projects. You guys have a great day, and I don't know, maybe I'll see you tomorrow again.